this is derivative of function. So derivative of function, it is definition we define like this. Fx is a real valued function, and derivative of fx is defined as a limit of this delta y by delta x, and delta y means f of x plus delta x. When fx is a function, we are giving increment delta x, then f of x plus delta x we will have some value, then this difference, it is delta y. So this is delta x, this is delta y, then this ratio delta y by delta x, and we make this limit as delta x tends to 0, and this gives us the derivative of a function with respect to x. So physical interpretation is, so this is when it is the rate of change of y with respect to x. So x is equal to ft if it is a velocity, it is a distance, then f dash t naught, derivative of this represents the speed of the particle at that point t naught. Geometrical interpretation is, this is del dy dx at x equal to x naught, it is the gradient of the tangent. So this is the tangent is this red line, so delta y, it is at this point. So this is a is the second, then it is approaching to e is approaching to a in this way. So delta y also approaching to this point, and delta x is approaching to 0. So this becomes this second becomes the tangent at the point a. So this is interpretation. So this is to be remembered. Y is equal to fx is a real valued function. Derivative of fx at x equal to x naught is equal to we say it is f dash x naught. We denote by this dash. F dash x naught means derivative of fx at the point x equal to x naught. F dash x naught, this is dy dx at x equal to x naught. It is a gradient of the tangent to the curve y is equal to fx at the point x naught y naught. Y naught is equal to fx naught. So differentiation from first principle. So first principle is that this limit. So ddx of dy dx, this is the first principle. Delta y by delta x, where delta y is this one. Then fx is given as x to the power n. So f of x plus h is x plus h whole to the power n minus x to the power n divided by h. H means delta x. Then it is approaching. So this one, this is a formula. This is a formula for limit. So this limit is n into 8 to the power n minus 1. So here a is x and x is this x plus h. So x plus h tends to x means h tends to 0. So it is n x to the power n minus 1. So this is a formula. So ddx of x to the power n is n x to the power n minus 1. Then this is from first principle, e to the power x. So ddx of e to the power x, it is f of x plus h minus fx by h, and f of x plus h is e to the power x plus h. Means what? E to the power x is fx, in place of x we are placing x plus h. So then we simplify, e to the power x is taken common, and it is e to the power h minus 1 divided by h, and this is a standard limit. This e to the power h minus 1 by h as h tends to 0 is 1. So this limit is 1, so remains e to the power x. So ddx of e to the power x is e to the power x. Similarly, a to the power x, e to the power x is a to the power x. This is also by formula we are having this like this same. So e to the power x is taken common, e to the power h minus 1 by h, and this is a result of limit. This limit is log of e to the base e. So this is e to the power x, and this limit is log of e to the base e. Then this log of x to the base e, log of x to the base e, it is when we write f of x plus h, it is log of x plus h, and log a minus log b is log of a by b, so it is x plus h by x. Then we are simplifying this, and we are applying this result. Log of 1 plus x by x as x tends to 0, when base is e, this limit is 1. So this limit is 1 and remains 1 by x. This is from this calculation. Then sin x. Sin x is this is f of x plus h is sin of x plus h, then minus sin x. Then this is sin c minus sin d. This is the formula, 2 cos of this x plus h plus x by 2. This is x plus h minus x by 2. So this is the formula. Then cos of x plus h by 2 after simplification. This is sin h by 2 by h by 2, and this limit we know, sin theta by theta as theta tends to 0, this limit is 1. So it is cos x, h by h tends to 0, x remains, this is 0, and this is cos x into 1, it is cos x. So ddx of sin x is cos x. In a similar way, here also it is cos c minus cos d formula, applying this, and it is again sin theta by theta as theta tends to 0 is 1. So this h by 2, it is 0, so it is minus sin x. So ddx of cos x is minus sin x. So these are the formula we are deriving from first principle. Then some rules are there. Derivative of a constant is 0. So constant means it is always same value. So whatever increment we are giving, fx x plus h increment, that value is always c. That is why it is constant function. So it is c minus c. So ddx of the constant is 0. Then ddx of c into fx. C is constant, then c is taken outside. We will consider this. We will take the derivative of this. So it is c into f dash x. Like this is a result. This is an example. So 4 is constant, 4 is taken outside, then x square, it is x to the power n. So n is 2, so 2 into x, so it is twice x, it is 8x. Then fx plus minus zx. So it is the example explanation. So fx is x cube, zx is sin x. So x cube minus sin x. So x cube derivative of x cube is 3x square, and minus the derivative of sin x is cos x. Then product rule. Product rule is, so this is a product. So first two functions are there, so we take derivative, then multiply by the this function zx, then plus fx is taken as it is kept as it is, and we take the derivative of cx. So it is ddx of e to the power x sin x is e to the power x into, means ddx of e to the power x is e to the power x, then sin x remains same, plus e to the power x remains same, then ddx of sin x is cos x. Quotient rule is this, when it is a fraction fx by zx. So what we do, denominator it is square, then ddx of fx into zx minus. So in case of product rule it is plus, but here here it will be minus fx into ddx of zx, and denominator is zx whole square. So explanation is sin x by cos x, so it is cos square x, then ddx of the numerator, it is sin x, then into cos x the denominator, then minus sin x into ddx of cos x. So what we get, ddx of sin x is cos x, so it is cos x into cos x is cos square x, then ddx of cos x is minus sin x, so it is sin plus sin square x, it is 1, so it is 1 by cos square x, so it is sec square x. So this is quotient rule. Then chain rule. Chain rule is, suppose we are having function of functions like this. I am explaining this, sine of x square. So sine of x square, so sine, if we know the derivative of sine x, but we don't know what is the derivative of x, sine of x square. So what we do, so it is, we write x square as u. So x square as u. So when it is u, we need to take derivative with respect to u. So it is sin u ddu of sin u. We are replacing this as u, and we need to take derivative of with respect to u. So because we need with respect to x, so what we do, it is du dx, means u is x square with respect to x. So this is chain rule, function within functions. So it is so it is cos u into d dx of x square, it is twice x. So cos u, again u should be written as x square, so it is twice x into cos x square. This is parametric function. So parametric function is, parametric function is what, x and y, there is relation between x and y, but at the same time x is function of some one function of some, they are function of some common parameter, so t. So x is function of t, y is function of t, so t we say it is a parameter. Then we can find dx dt, we can find dy dt. So dy dx is dy dt by dx dt, it is parametric function. So for this function, what we have, dy dx is, dy dt is twice t and dx dt is 4, so it is t by 2. And this one is for implicit function. So implicit function is, this is when y is not expressed as function of x alone, so it is in between this, so we cannot separate y. So what we do here, this is equal to 0, we write this implies sign, so take derivative, both side we take the derivative. So d dx of sine of x plus y, it is again applying the chain rule. So cos sine function, it is cos function x plus y, then d dx of x plus y plus d dx of x cube is 3x square, d dx of 2 is 0, right side is 0. This implies cos of x plus y. Now d dx of x plus y, so d dx of x is 1, and with respect d dx of y, we need to write here dy dx, so plus 3x square. Now we separate this dy dx, so dy dx is now this minus 1. So this is a way to do derivative of implicit function. This is implicit function. Now these are some examples. Y is equal to 10x. This is we applied, we explained in the quotient rule. Then this is also quotient rule. Cot x, d dx of cot x is cos x by sin x. So this is the denominator is sin x, so sin square x. Then d dx of cos x into sin x minus cos x into d dx of sin x, so it is minus cos x square x. This is just calculation. So d dx of sec x, so sec x is 1 by cos x, so 1 by cos x means cos x to the power minus 1. So cos x to the power minus 1, so cos x to the power n, it is chain rule. It is chain rule. This chain rule. This is chain rule. So cos x to the power minus 1. So when we need to take derivative of d dx of this, means what, we are writing cos x as u. So cos x as u means du dx, d dx of u to the power minus 1. So this will be dd u of u to the power minus 1 into du dx, du dx. And now it is minus, this is minus 1, it is the x to the power n formula, u to the power minus 2 into du dx is, u is cos x, so cos x, the derivative of cos x is minus sin x, so it is minus 1 by u square. So u square means cos square x into minus sin x. So what we are having, this is sec x tan x. After simplification, it is sec x sin x. In a similar way, this is also same thing. We are taking u as sin x, then d dx of, this is minus 1 u to the power minus 2 into du dx. Du dx is cos x. This is sin inverse x. Sin inverse x is x is equal to sin y is equal to sin inverse x, means x is equal to sin y. So dx dy is, so here you consider x is function of y. So dx dy is cos y. Cos y means root over 1 minus x square, because x is sin y. So cos y is root over 1 minus x square. It is trigonometric result. Then it is dy dx is 1 by root over 1 minus x square. Then tan inverse x, same procedure. Sec inverse x, these are the same procedure. Dx dy, we are doing by dx dy, keeping y as independent variable, and then again reciprocal of dx dy. So these are the formula at a glance. This formula you need to remember. This formula you need to remember. You have derived earlier. So these are the formula. Now these are worked out examples. So 5x square minus thrice x plus 8, it is 5x square, it is 5 into twice x minus 3 into 1 plus 0, it is 10x minus 3. Then 8 into x to the power 6 minus x to the power 4 plus 8x square minus x. So it is 8 into, this is x to the power 6 is 6x to the power 5 minus, this is x cube, x to the power 4, it is 4x cube, then plus 8 into twice x minus d dx of x is 1. So these are all algebraic. Now this one, 5 into x plus 2 whole square. So here we apply a chain rule, or not chain rule, we are expanding this. So x plus 2 whole square is x square plus 4x plus 4, then minus 4x plus 8. So this is by expansion. So we are simplifying this. This is an algebraic function, polynomial it is. Then sin x minus cot x plus x to the power 4. So d dx of sin x is cos x, cot x is this one, and x to the power 4 is 4x cube. So this is the result. Then root over x plus 1 by root over x whole square. So we are expanding this. Root over x whole square is x, then twice ab, it is 2 only, and 1 by root over x whole square is 1 by x, it is 1 plus 0 minus. So d dx of this is this one. Then cosec x minus 3 cot x plus 2. So minus, so d dx of cosec x is minus cosec x cot x is minus cosec square x, d dx of 2 is 0. 4 to the power x, x to the power 4. So this is d dx of 4 to the power x is 4 to the power x into log of 4 to the base e. It is 8 to the power x formula. d dx of this formula, d dx of a to the power x formula, where a is equal to 4. Then x to the power 4 is x to the power n formula, it is 4x cube. Then e to the power x minus 2 to the power x plus x square. So e to the power x, it is e to the power x minus 2 to the power x, it is e to the power x formula, it is e to the power x into log 2 to the base e. Then x square, it is twice x. Then this is with respect to t, it is function of t. So it is 6 into t cube plus 1 minus 5 sin t, then 6, then into 3t square plus 0, this one, 1 by root over u with respect to u we are doing. So u to the power minus half, 1 by root over u means e to the power minus half. So it is minus half is n, then minus half minus 1 plus e to the power u, derivative of e to the power u is e to the power u. Then e to the power minus 3 by 2 we can write like this, u root over u. So this is the result. Next, this part, fx is 3x square x cos x plus 2 sin x. So here we apply product formula, x cos x like this. So this one, 3x square x cos x, it is 3x cube cos x, so it is d dx of x cube cos x. And this one is 3x square, so say 3 into 2, it is 6, so 6 is taken outside, it is x square sin x. So it is product formula 3 into the d dx of 3x square, d dx of x cube is 3x square into cos x plus x cube into d dx of cos x is minus sin x. And for this, twice x into sin x plus x square into d dx of sin x is cos x. Then it is minus 3x cube minus 3x cube, this one is x cube sin x, then it is 15. So in the reducing this power, so first it is x cube, then x square, then x, then f dash x is for this function f dash x to the power x sin x. So again it is product formula, so x to the power 6 into sin x. Next, this is also product formula, it is this e to the power x, so d dx of e to the power x is same, it is e to the power x. So this is 6 into x to the power 5, and next it is, so e to the power x remains same. Then x to the power 7 to the power x, so here 3 functions are there, 3 products. So first taking derivative of x to the power 7, and this is taken as one function to the power x log x to the base c. Then x to the power 7, then d dx of this one to the power x log of x to the base e. Again it is product formula, so it is 7x to the power 6, this one is remaining same, then x to the power 7, then within bracket we are writing this product formula as this. So to the power x, d dx of to the power x is to the power x log to the base e into log of x to the base c plus to the power x, then log of x is derivative is 1 by x. So this formula log x, this to be point to be noted that the base must be equal, base should be e, then only we get 1 by x. Then this is nothing but the simplification, and it is again it is product formula. Then this is also same, 3 functions are there like this. Then x cube sin x, again it is product formula. Then so these are just examples. X by d dx of x by sin x, sin pi by 3, sin pi by 3, number 9, what is this, then number 9, or this one, sin pi by 3. So sin pi by 3 is just a constant, so x by sin x, so x by sin x we write x cosec x, then sin pi by 3 is root 3 by 2, value we are writing, then it is a product formula. So first d dx of x is 1 into cosec x minus x into d dx of cosec x minus cosec x cot x. So these are all this is division, fraction. So 1 plus sin x whole square, then numerator derivative is e to the power x into denominator minus then numerator into d dx of the denominator. D dx of the denominator means d dx of 1 is 0, d dx of sin x is cos x. Then simplification is this one, then 1 minus cos x by 1 plus cos x, it is again this, and this number 12 we can write like this also, number 12 we can write this also, 1 minus cos x is what, by trigonometric formula 1 minus cos x by 1 plus cos x is 2 sin square x by 2 by 2 cos square x by 2. It is tan square x by 2. So we can do like this also. So d dx of 1 minus cos x by 1 plus cos x, this can be written as d dx of tan square x by 2. Now what we have here, we are applying chain rule. So first it is square function. So first we write tan u is equal to tan of x by 2. Then we write z is equal to x by 2. Z is equal to x by 2. So first it is u square, then it is tan z. So first it is function of, so to get ddx of this, we will do it like this: ddu into u square, then du. So u is tan z, so ddz of tan z into z is x by 2, so ddx of x by 2. So this is the chain formula. So first it is function, we consider as square function, then it is tan function, and then it is x by 2. So we will have now twice u means 2 tan of x by 2 into tan z it is sec square, so into sec square z means x by 2 into ddx of x by 2 is half. So here we write this bracket, because otherwise we will write x by 4. So ultimately what we have, 2 goes, it is tan x by 2 into sec square x by 2. Tan x by 2 sec square x by 2. If we simplify this one, we will have the same value. So it is in the half, if we write in the half diagonals, it is 2 sin x by 2 cos x x by 2 divided by 1 plus cos x is 2 cos square, so it is 2 cos square x by 2 whole square. Will you get it? We need to have tan x by 2 sec square x by 2, 2 sin x by 2, 1 plus cos x, so sin, so tan sec square, so it is 2 by it is 4, 2 sin x by 2, so it is 4, sin x is 2 sin x by 2 cos x, also another 2 is here, so this is 2 into, so it is 4 goes with this, then sin x by 2 by cos x, here it is 4 cos square, so it is 4 cos are there, so sin x by 2, sin x is cos x by 2, 1 cos x goes, so 4 goes, this will have 4 goes, we will have sin x by 2, 1 cos, I am taking here from the denominator, this is 2, then 1 cos goes with this, then remains here cos square x by 2, so this cos square becomes sec square, so ultimately we get this is tan x by 2 into sec square x by 2, so this is tan x by 2 and this 1 by cos square, this becomes sec square, so ultimately result is same, this is in terms of x and this is in terms of half diagonal. So in this way also we can do it. Then it is again these fractions, so these are all this. Now this one is at x is equal to -1, so f dash x, we are finding this, we are getting these values, then at x equal to -1, so after getting this f dash x, we need to write x equal to -1, so it is in place of x square we write -1 whole square, it is -4, then plus 16 into -1, it is -16, then it is -1 whole to the power 4, it is 1, it is 16, so it is -5 by 4. So when we have to write the derivative at some specific value. First we need to find the derivative of the function, and then we have to write that value for x. So this is f dash x, and then we need to write x is equal to pi by 3 here. So x equal to pi by 3, so this value we are putting it. So these are the this twice pi by 3, it is remains like this is x square. Then this for 10 we have these values root 3. Then 1 by cos twice x. So in place of this is trigonometric result, 1 plus cos twice x, we are writing 2 cos square x, then root 2 will come out, then it is cos x, then this is the dx of cos x is minus sin x, and at x equal to pi our value is minus root 2 sine of pi, it is equal to 0. So these are the results. Then derivative of sine of x square, these are chain rules. Sine of x square plus 2, all are chain rules. So ddx of sine of x, so sine first it is sine function, so it is sine ddx of sine is cos, then it is x square plus 2. So cos ddx of sine is cos, then it is remaining this x square plus 2, then ddx of x square plus 2 we have to multiply by this, so it is twice x into this. Sine cube twice x. So first is cubic function, so first it is sine cube twice x. First it is u cube, then it is sine z, and then it is twice x. Means what? So what we should do, dd u of u cube, then u is function of z, so dd z of u into dz x of this twice x, or z we can write. So it is 3u square. 3u square means 3 sine square, 3 sine square. Z, this twice x is kept like this, 3 sine square. Oh, it is not this one, it is actually sine. First it is then we need to multiply by sine square. First it is 3 sine square, then cos into cos of twice x, ddx of, so sine function, it is derivative is cos twice x, then into ddx of 2. So actually this result is, it is wrongly written, this result is 2 into 3, it is 6 sine square twice x into cos twice x. Then cos 5x is minus cos, first is cosine function, it is minus sine, so minus then ddx of 5x is 5, so it is minus 5 sine 5x. Then sine inverse, so first it is sine inverse function, so 1 by root over 1 minus x square, so this one is 1 by, so it is 1 by, so sine inverse, so first it is sine inverse u, and then u is e to the power x, so it is dd u of sine inverse u into dd x of u means e to the power x. So sine inverse u means it is 1 by root over 1 minus u square is e to the power x whole square, it is twice x. into e to the power x, derivative of e to the power x is e to the power x. So this one is e to the power x by 1 minus root over 1 minus e to the power x. Then this is again chain rule. Cos of root over x, it is e to the power cos root over x. So first it is u, then it is cos function. So ddx of cos root x, ddx of cosine is minus sine, then again root over x, ddx of root over x, it is this one. So it is 1 by 2 root x. So this one, x square minus plus 1 denominator, we have to square it. So it is x square plus 1, then 3 to the power ddx of 3 to the power x is fraction. So it is numerator, ddx of the numerator. So ddx of 3 to the power x is 3 to the power x into log of 3 to the base a into cos x minus 3 to the power x into ddx of cos x is minus sin x. So this is the derivative of the numerator, into denominator is kept as it is, root over x plus 1 minus then 3 to the power x into cos x, it is kept as it is, and then ddx of the denominator is, so ddx of root over x square plus 1. So let us see ddx of root over x square plus 1. So ddx of root over x square plus 1. So first it is square function, square root function. So it is 1 by, so if it is u, then 1 by 2 root u. 2 root u, root u means x square plus 1 into ddx of x square plus 1 plus 1. So it is twice x. So it is twice x by root over x square plus 1. Twice x by 2 is here, twice x by this 2 is here, 1 2 is there, 1 by 2 root over x square plus 1, this 2 goes, it is x by root over x. So this is not here. So x square, 2x square plus 1, 2 goes, so this one. Then tan of e to the power sin x, it is first it is tan function, so it is x square e to the power sin x, then into ddx of e to the power sin x is e to the power sin x, and then sin x, derivative of sin x is cos x. So in this case sin x twice x, we are writing like this, 2 sin a cos b, it is this is the trigonometric result. 2 sin a cos b is cos of a minus b minus cos of a plus b. So cos of a minus b, it is cos x minus cos of a plus b into cos of 4x. So it is cos x cos 4x cos thrice x cos 4x, these are product functions, and I can do this like this. Then sec x plus tan x, then x sin square x plus root over 1 minus x square. So it is x sin square is as x sin inverse x is a product function. So it is sin inverse x, ddx of x is 1 into sin inverse x plus x into ddx of sin inverse x is 1 by root over 1 minus x square plus ddx of this one. So it is ddx of root over u like this. So it is 1 by 2 root over u, and ddx of 1 minus x square is minus twice x. So after simplification we get like this. Then 1 minus sin x by 1 plus sin x. So because it is logarithmic, so half is taken outside, then ddx of 1 minus sin x we can write as log of m by n is log m minus log n. So log of this one minus this, then this half, then it is log x derivative is 1 by x, so it is u, so it is 1 by u. So if log of, it is log u, so where 1 minus sin x is u, so it is ddu of log u into dd x of u. U means 1 minus sin x. 1 minus sin x. So 1 by u. U means 1 minus sin x. This is 1 minus sin x, and ddx of sin x is cos x. Ddx of 1 minus sin x is minus cos x. So after simplification we get it this. Then 4x e to the power 6x. So these are all examples. It does explain these things. Root over 1 plus x by 2, it is 1 by 2 root over this one. So this, then sin x by cos x, applying trigonometric formula we can reduce it to tan x by 2 by this application. So it is tan inverse of tan is it goes cancels, so ddx of x by 2. So it is half. Then sin cos, so these are sin inverse x plus cos inverse. This is also trigonometric result. Sin inverse x plus cos inverse x is pi by 2. Then this is again chain rule. ddx of this is 1 by 2 root over, so number 8, this one is 1 by 2 root over 1 plus x minus x to the power 4 if it is u, into ddx of 1 plus x minus x to the power 4. So this is equal to, this is 2, this is root over 1 plus x minus x to the power 4, and this is 0 plus 1 minus 4x cube. 4x cube. So this is wrongly written. This is, answer should be this one. This is, it is, denominator is 2 root over 1 plus x minus x to the power 4, and numerator is not x, it is 1 minus 4x cube. So these are the worked out examples. At x equal to half we need to find the value. So at x equal to half, minus 1 minus, so minus 4 by 8, no, it is not this one, so we need to follow that one. So this is equal to 1 minus 4 into 1 by 8, then 2 root over 1 plus half minus 1 by 16. So it is 4 2 half, it is 2, 1 minus half, so this is equal to half, it is 1 by 4, then root over this, this is 16, and it is 16 plus 8, it is 16 plus 8, it is 16 plus 8, it is 24, minus 1, it is 23. So this is 16 root over, it is 4, so this gets cancelled, so it is 1 by root over 23. So this is the value. Then this is log of x plus root over x square plus s square, it is 1 by, so 1 by 2, ddx of x is 1. So first it is u, then 1 by u into ddx of this one. So ddx of x is 1 and ddx of root over x square plus a square is 1 by 2 root over x square plus a square into twice x. Actually this formula say ddx of root over x, we can do it as, we can write it 1 by 2 root x. So this is root over, so x is derivative is 1 and this one is 1 by 2 root over x square plus s square, and then ddx of x square plus s square. ddx of x square is twice x and s square is 0. So this is the result. Then these are parametric functions. So parametric function, these are simple functions, you can have it. So dx dt is 60, dy dt is 6. So then divide, it is 1 by t. dy dx is at t equal to 2, it is putting the value t equal to 2, it is half. Then a sin t, a cos t, ddx of a t plus sin t is this one. Then dy dt at t equal to pi by 2, we are putting the value t equal to pi by 2, it is 1. Then this one e to the power u this value, so this parameter is u, so we have to find dx du, dy du. This is then dy dx, then this is function of t, parameter is t. This one at t equal to 4 we need to find, so t equal to 4, and thus this value is, we are putting, after getting dy dx, then we put t equal to 4. So these are parametric functions. Then these are some examples. This is implicit function. So implicit function, so y equal to x to the power x, we take it this logarithm. So log y is, so when we take log y, when we take logarithm, then this becomes a product function. So ddx of log y is, first it is 1 by y into dy dx, and right hand side is only a function of x, it is this one. So dy dx is separated like this. Then this one is again after taking logarithm, it becomes product function. Then y derivative of y is we have to write it as dy dx, then log x to the base e, it is derivative of dx is x, then log so it is dy dx into log x, and 1 by x is the left hand side, and it is ddx of x is 1, then log y, then this is chain rule, ddx of log y is 1 by y into dy dx, and x is kept as it is. So dy dx is simplified like this. Then again it is x to the power sin x, so taking logarithm, it is log y equal to sin x log x. So these are the implicit function examples. So this one 1 by this is x plus root over 1 plus y, so derivative of x is 1 into root over 1 plus y, then ddx of, so x is kept as it is, then ddx of 1 root over 1 plus y, it is root over means it is 2 root over 1 by 2 root over 1 plus y, then ddx of 1 plus y is 0 plus dy dx, plus for this part derivative of y is dy dx into root over 1 plus x, then y into ddx of root over 1 plus x is this one. Then we separate this dy dx, and then we divide by this, we get this result. So this after taking derivative, we need to put the value x equal to 1 and y equal to pi by 4. So these are the examples of implicit function. Okay, thank you.